All right, so we are on page 324 today in the Red Book. Page 324 in the Red Book. Now, when I give you the assignment at the end of the notes, I'm giving you permission to take your phone out and take a picture of the page in the textbook in case you don't finish the problems in class. You'll have a picture of the problems. Got it? All right, so you have permission to do that each day in class since you don't have access to this Red Book outside of class. So today we're talking about perpendicular bisectors. And you've got a perpendicular bisector theorem there on page 324, 5.1. And it states that if a point is on the perpendicular bisector of a segment, then it is equidistant or equal distance from the endpoints of the segment. And what a picture of that looks like is, so let's say you got a segment. And what the theorem says, if a point is on the perpendicular bisector of a segment. So here's a segment. Let's say you got AB or AC. A perpendicular bisector would go right through it. It would intersect it at 90 degrees, perpendicular, intersects at 90 degrees. And if it's a bisector, it cuts it into two equal pieces. So in this case, if this point right here, the point of intersection is point B, then AB is congruent to BC. And if we call this EF, then EF is a perpendicular bisector of AC. What the theorem says is that any point on EF, so if I put a point up here at E, that E to A is the same distance as E to C. Okay? Anywhere that you go along this perpendicular bisector, if you put a point right here, the distance from this point to A is the same as this point to C. All right? From F to C is equal to F to A. Any point on this perpendicular bisector is equal distance from the end points of the segment. So if you draw in this segment, here and here, these two pieces are congruent to each other. If you do the same from F to C and A to F, those two pieces are congruent to each other. Everybody okay with that? Right below it is the converse of the theorem. You need to get that in your notes as well. Converse of the perpendicular bisector theorem. And it states that if a point is equal distance from the endpoints of a segment, then it is on the perpendicular bisector of the segment. All right, so look at the top of page 325, and you're asked to find each measure. And this first problem, they're asking you to find AB. And here's your picture. All right, so look at this picture. You've got this line, this horizontal line that cuts segment BD into two equal pieces, and it intersects it at 90 degrees. So it's a perpendicular bisector, right? It's just going the other direction. That means that point A is the same distance from B as it is from D. So how far is it from A to B? Good, 4.1. Now, if you had this same picture and you needed to, no, we're going to draw a new picture. Let's go this way again. We're doing that. We're still doing example 1. It's the next diagram on page 325. So you've got WZ here and point X up here. And point X is 9 units from W and it's 9 units from Z. And there's a Y right here. This is point Y. So if X is the same distance from W as it is from Z. That's the converse of the theorem. If a point is the same distance from the endpoints of a segment, then it is on the perpendicular bisector. So if this vertical line is the perpendicular bisector, then doesn't it cut WZ in half? It bisects it, right? So if Y to Z is 3, how far is it from W to Y? This would be 3 as well. So W to Y is equal to 3. Get the idea?
Yes.
Good. So let's do one more. Got a horizontal and then a vertical QT. Point R is up here. And then Q to R and T to R. Point S, a 90-degree angle, and 2 congruent segments. So that makes, based on this information, all right, if QS is the same distance as ST, and RS intersects it at 90 degrees, it's a perpendicular bisector. And R is the same distance from Q as it is from T. But now you're given Q to R as 2x plus 3, and T to R is 4x minus 7. And you're asked to find R to T. So in order to find RT, you need to solve for x first. So your equation is going to be 2x plus 3 is equal to 4x minus 7. So I would subtract 2x from each side first. And 3 would be equal to 2x minus 7. Add 7 to each side. So 10 would be equal to 2x, and then divide by 2. So 5 is equal to x. And R to T would be equal to 4 times 5 minus 7. Four times 5 is minus 7. 13. Very good. 20 minus 7 is 13. All right, so any questions on perpendicular bisectors? They cut a segment in half, and any point on the perpendicular bisector is equal distance to the ends of the segment. All right, your practice is going to be on page 329. Problems 1 to 3 and 9 to 14. You've got 8 Alex topics this week. Those are due on Fridays.